Good evening, Internet. I am Matt Buyak, and in this video we will solve the 24th problem from the Project Euler problem archive. So this problem asks us to consider permutations on the digits 0 through 9 and asks us to find the millionth such permutation. Now there are certain problems which might be harder to solve in C++ than in other languages, and there are problems which maybe are easier to solve in C++ than in other language, though I feel like the former are perhaps much more common than the latter. In this case, C++ does have a function, next permutation, which is going to allow us to solve this problem pretty trivially. And so let's get into it. As usual, we'll copy our template directory to make our problem directory. And I believe it was algorithm is the, yes, algorithm is the header file we'll need. Let's see, let's say digits 10. Recall we'll need, we have 10 digits, but we need one more byte for the terminating 0, and so we'll say 11 is equal to 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And we'll need an index. So one thing to be careful about here, we want the millionth permutation, but we're starting with the first permutation. And so we don't actually want to go all the way to, we don't want to iterate 1 million times. We want to iterate 999,999 times. So then we'll say, we just check the syntax that it is expecting. Yeah, so it just wants a pointer to the first and last elements. So I believe we should be able to do next permutation, and it's going to be address of digits 0 and address of digits 11. Okay, so obviously something has gone wrong because, I expect that my understanding of the, oh, I see, okay, it wants actually the pointer to the last element, not the pointer just past the last element. And so I was misunderstanding the usage there. There we go. That looks much more reasonable. And so that's going to be, looks like 2,783,915,460. And so let's go back to the archive and check our answer. It's being a bit slow this evening. There we go. Okay. And you can see that that matches our expectations. Now, for the next video, we're not going to go directly on to problem number 25. You'll see that problem number 25 involves finding the first Fibonacci number, which contains 1,000 digits. And it turns out that we can actually solve this using analysis alone. But we've also been working on a big integer class, which allows us to work with large integers. And so this is a nice excuse to add addition to our big integer class, and in particular, addition between two big integers. And so in the next video, I'll be doing another segment in my series on big integers and adding that functionality. And then the video after that, we will solve problem number 25. And then I will do an additional video on problem number 25, solving it using analysis alone. And so if those sound interesting to you, then you can look forward to those in the next few days.